Let's do LeetCode hard question 85, maximal rectangle. This question is asking you if you were given a matrix filled with characters 0 or 1, how to find the largest rectangle that containing only 1 in this metric. I think it is possible that you use a traditional DFS and only constrain the direction to in 2 directions rather than 4, so to guarantee the shape is a rectangle. But today I want to discuss the solution that is more intuitive for me, which is very closely related to the problem 884. I think the name is maximal rectangle for in histogram. In that question, it is first of all, if you haven't done that question or you are not super comfortable with that solution, you definitely should make sure you fully understand that one before moving to this one, because this question is literally the same logic and data structure using in a 2D array, which is a matrix here, rather than 1D array. For this question, the only difference is just 2 more lines to first iterate, which is in a for loop, iterate this extra dimension, and the second is to accumulate all the changes caused by this extra dimension. The rest are pretty much identical, except one we need to handle exception, which I don't think is a part of the logic. So this is another difference. So follow the same logic of using monotonic stack. We want to guarantee all the values get popped out at the end. So we want to append a 0 to the end of the heights we're going to use. And another thing, a little bit different, but it's the same logic, is we initialize it with 0 rather than given. We are not given the heights directly this time. We have to read every value ourselves. And similarly, we need a return value, which is the area of the rectangle. And next, we can iterate all the rows, and for each row you apply the same logic as if it is question 884. So that is this logic, but before that you need to first read all the value. So for IV in each row, and this is the only difference between those two questions. For each row, you want to update the heights, and the logic is very straightforward. If it's 1, that means this bar is continuing, then you should plus 1. Else it should be reset to 0. And that's all the extra work for this question. And now you can use a stack to get the maximum rectangle formed up to this row. While the new incoming height is lower than all the heights in the stack, we should keep popping until the current one is the highest one. Again, we don't need to check if stack is empty because we put this we put this extra 0 here, and we put I forgot this step actually, -1, and that will always be lower than all the heights, so we never need to worry if the stack is empty because it will never be. If the new one is lower, then we should keep popping And when we pop, we can update the area because we are able to calculate the new area, which is height minus width, and the height is the one being popped out, and the width is the current index minus the last index, which is the last index after the previous last one being popped out. And after that, we can safely append the new stack, append the new height to the stack. I like using this one to maintain this increasing stack. Now that's all. Sorry, I always mess up the height and index. So inside the stack, each element is an index, not the height. When you compare, it is a height. And I just noticed I totally didn't append that extra 0 there. So that's all. The only difference compared to question 84 is you have this extra step to go through each row rather than you were given only one row.